Good morning, class. Today, we are going to dive into one of the most versatile and widely used components in digital electronics, the JK flip-flop. If you remember our discussion on SR flip-flops, you'll recall there was a forbidden state when both inputs were high. The JK flip-flop is essentially the refined version that solves that problem. 1. What is a JK flip-flop? Think of a JK flip-flop as a memory cell. It is a sequential logic circuit, meaning its output doesn't just depend on what you're giving it right now, but also on what it was doing a moment ago. As you can see in the diagram, we have two main inputs, J, set, and K, reset. We also have a clock, CLK, signal. This is the heartbeat of the circuit. Nothing happens until the clock gives the go-ahead. We also have asynchronous inputs like preset, PR, and clear, CLR, which can force the state regardless of the clock. 2. How it works, the truth table. Let's look at the 4 operational modes. This is where the magic happens. No change, J equals 0, K equals 0 if both inputs are low. The flip-flop is in hold mode. Whatever value is there stays there. Reset, J equals 0, K equals 1. This forces the output Q to 0. Set, J equals 1, K equals 0. This forces the output Q to 1. Toggle, J equals 1, K equals 1. This is the breakthrough. Unlike the SR flip-flop, where 1 to 1 was an error, here it toggles. If it was a 0, it becomes a 1. If it was a 1, it becomes a 0. It's like a light switch. 3. The characteristic equation. To describe this behavior mathematically, we use a K-map to derive the characteristic equation. By grouping the 1s in our truth table, we get this formula. This formula allows us to predict the next state, Q underscore n plus 1, based on the current inputs and the current state, Q underscore n. Why excitation tables matter. Now, if you are designing a counter or a complex digital system, you often know where you are and where you want to go. For example, if the current state is 0 and you want the next state to be 1, what should J and K be? Looking at our excitation table, J must be 1, but K can be anything, indicated by X or don't care. This flexibility makes the JK flip-flop incredibly efficient for circuit design. Summary. The JK flip-flop is the jack of all trades in digital logic. It eliminates the invalid states of its predecessors and gives us the powerful toggle function, which is the foundation for almost every digital counter and timer you use in your technology projects today.